So for the final part of the conclusion, we are going to talk about the sample variation. And remember, sample variation and sample variability is this idea that every single sample we take from a population is going to be slightly different. We're not always going to get the same sample. One might be slightly better than another. They are going to sort of mostly be the same if they're good samples, but you might have some variation between them. So we need to talk about how we can reduce it, and then we need to predict what might happen if we took another sample that was much bigger than the one we just did for this write-up. So, important things to cover off here. This is only one sample of each, and other samples would give different statistics due to sample variation. Very important. Again, that idea, sample variation will have different results for us, or different statistics. So, however, the calculated confidence intervals allow for this variation in samples, so the population median should be within the confidence interval of each sample. It's our second very, very important thing. Right? We just calculated this confidence interval, and we're making an inference from that, saying our population median should be somewhere inside of that confidence interval. I'm not sure where, but it's likely that my population median would be between 144 and 167 for apple trees near the river. Okay, so again, this is why we have a confidence interval, because it's going to give us a range of values that allow us to make some sort of accommodation at the fact that every single sample might be slightly different, and they might not be exactly what the population is, but they'll be close, and if we have a range of values, we might be able to predict what the population median is likely to be. Next, we need to talk about sample variation. So sample variation can be reduced by using a bigger sample size. Alright, we used 30. So bigger samples will make the size of the confidence interval smaller. And again, it's this idea, as n gets bigger, the confidence interval gets smaller. And if your confidence interval is smaller, you're going to have a better idea about what's going on in the population. So bigger samples will make the size of the confidence interval smaller. The smaller confidence intervals will give a more precise idea of what the population median for each group may be. Right? If I have to take a guess for a confidence interval that wide, I'd probably have not as good of a guess as if I only had a confidence interval that wide, right? So the population median could be here, or anywhere inside that confidence interval. So it's a lot of area to guess inside of. But on a smaller confidence interval, well, they're all a lot closer to each other, so any guess is probably similar to another, and you're more likely to get close to it. And our third part here then, making our prediction, if I took a larger sample, the confidence intervals would be smaller. This idea again. The medians will be different too, because of sample variation. But in this case, the confidence intervals are already well separated with no overlap. So even with a much larger sample size, it seems likely that I will make the same conclusion, that the trees near the river produce more apples than the trees far from the river. And again, this is the idea that currently my confidence intervals look something like this, and they're pretty well spread out. We can just go up and look at the graph. So currently my confidence intervals look like that. You can tell that there's no overlap between them. They're really far apart. And if I took a bigger sample, I'd expect things to move around slightly. I might get a slightly different median, I might get slightly different results here. But no matter what, my confidence intervals are going to be a lot smaller, and they're probably going to be in a similar area, right? So with a smaller confidence interval, it's even less likely that I'm going to get overlap because they're already so far apart. So if I took another big sample, to get a different conclusion, I'd have to have my confidence intervals overlapping each other. And in this case, like my new samples would have to be so much different than what I have here that it seems really unlikely that that's going to happen. Right? There's so much distance between the confidence intervals here. I'd have to get new samples that are, half the distance apart from each other, or maybe like 2 times, 3 times closer to each other. And my confidence intervals would have to be, smaller. They would be smaller, so I'd have to get it even closer together. And seeing that there's so much difference between these samples already, it just seems really unlikely. The means and medians are very different. There's no overlap at all. They're shifted further up the scale. There's just a lot of things here to suggest that there's a difference back in the population. And that's that idea that we're trying to get at here by making that prediction. It's kind of like, how confident are we in it? So again, if I took a larger sample, the confidence intervals would be smaller, the medians will be different too, but in this case the confidence intervals are already well separated. with no overlap, so even with a much larger sample size, it seems likely that I will make the same conclusion that the trees near the river produce more apples than the trees far from the river. And our last little token thing, I should say here, if you haven't also watched the video with more details on sample variability, please make sure you do it. It's just below. But for the conclusion, the last piece of this, which is important, again, you have to nail that off, is making a reflection on this. So it seems reasonable that trees near the river could produce more fruit because they have more water and more nutrients near the river compared to far from the river. The farmer may want to consider irrigating the trees far from the river so he can get more water to them and therefore maybe produce more apples. So just reflect on it. Does it make sense, for instance, that year 12 boys are taller than year 9 girls? You know, if you got a different result, for instance, that there was no difference in height between year 12 boys and year 9 girls, you might question that and think, well, this doesn't really make much sense to me. So that's kind of what this whole thing is, you know, does this make sense to you? And just talk about it. And is there anything that you could do to improve on the investigation too? But that's kind of what we talked about here, about taking a larger sample. So that's the last part of the conclusion, including the sample variability. So again, calculate your confidence intervals. Tell me where you think the population median might be. That's your inference, part 1. Second step, answer your question by using the confidence interval rule. Do you think there's a difference between these or not? Step 3 is long and drawn out, but you need to talk about your sampling variability. And you need to predict what might happen if you take a bigger sample. And your fourth part, again, don't forget it, even though it's kind of small, is make a reflection on your conclusion and what you think maybe you could do different next time or what might be better. And again, if you haven't watched the video about sampling variability to get this idea about what this paragraph is about more, go on and watch that as well.